Good evening to all dear participants. Am I audible? Thank you. So today going to start session on sample size calculation. Good evening to all. Without wasting time, I'm going to share here. And I think my screen is visible to you. And this. So it's day 2 sample size workshop. So here it's day 2. And sample size calculation day 2. So today we will discuss about one group we have done. One group, single mean, single group. Today we will discuss about two groups. So two groups, when comparison of two proportion is given. Two proportion means the outcome variable or primary outcome is a type of the frequency, percentage, qualitative type of. So there are two group. So group 1 proportion and group 2 proportion. So it is a two group proportions and we are comparing. Okay. And two groups, and these are both are like independent groups. Two groups when comparison of two means is given. So two proportion, for example, two proportion, we should take first two proportion, two groups. So group A or intervention, group B or control. So mortality in group A and mortality in group B. So mortality is a qualitative type of. We can get its percentage, proportion, frequency, etc. Okay. Then two group when comparison of two means is given. So there are two group A, group B, group 1, group 2, case and control, experiment and control. And we are comparing two means. Two means quantitative type of outcome variable. For example, mean hemoglobin level in group A, mean hemoglobin level in group B. We are comparing two. Okay. For example, systolic BP in mean systolic BP in group 1, mean systolic BP in group 2. For example, quality of life in group 1, quality of life in group 2. So these are type of two means. Now sample size calculation in RCTs, randomized control trial, when outcome is quantitative or numerical in nature, means quantitative or numerical means we are comparing two means. And sample size calculation in RCTs when outcome is qualitative or categorical or binary in nature. So what do you mean by qualitative, categorical or binary in nature? We are comparing two proportion. Okay. And RCTs or quasi-experimental studies, case control studies. Sample size calculation when effect size is given, we will discuss about these. And sample size calculation when medians are given instead of means. Yesterday we have done in one group. Okay. When medians are given, so what we have to do? We have to use that online link website, and then we have to like insert the values of median and interquartile range, or if we have minimum or maximum, we have to insert these value and we have to calculate, we have to estimate mean and standard deviation. And from these mean and standard deviation, we can calculate sample size using two means. Okay. Now, sometimes what happen, post hoc power calculation, when sample size calculation is not done before starting the study. So suppose we are the researchers and we could not calculate sample size priorly. Okay. And we have submitted our paper for publication. And the reviewers want, because you did not calculate sample size prior, so kindly calculate post hoc power calculation. So today we will discuss. And now there are some online calculator. We will today discuss about these sample size calculation using online calculator. Okay. So these are the prerequisites for sample size calculation in health research. We have discussed yesterday. So, and you have to remember all these things. Okay, what we need: primary outcome and proportion, prevalence, incidence, mean, standard deviation from previous study, pilot study, expert opinion, clinical experience, or based on our assumption. Okay, power of study, whether it is 80% or 90%, and confidence interval, usually we are taking 95% confidence interval. Okay, two-sided. 95% confidence interval, two-sided. One-sided in superiority trial and non-inferiority trial. So that we will discuss tomorrow. Okay. No shared screen. I think I have shared screen. Any problem with it? Can anyone confirm? Okay. Thank you. Thank you. Thank you. Thank you. Thank you. Yes, yes, yes. Thank you. Thank you. So, and we have, yesterday we have discussed types of the primary outcome in health research. So this is most important slide, I can say. On the basis of this type of outcome variable, that whether it is quantitative or qualitative, we have the formula of calculating sample size is different. Okay. Whether our primary outcome in quantitative in nature, we have to calculate mean, the formula is different. And if it is qualitative type of or descriptive, grouped or categorical or binary, then the formula is different. And we have to calculate frequency and percentage and proportion. So you have to remember this thing. Okay. And this is most important table to remember. Four values we have discussed yesterday. Okay. So in nutshell, if our power of study, that is if it is 80%, okay, so Z1 minus beta, or okay, the value is 0.842. If it is 90% power of study, the Z value, Z1 minus beta or Z beta, is 1.282. And next, if the alpha value 5%, it means 95% confidence interval. 100 minus 5, that is a 95%. So if it is one-sided, means 5%, okay, alpha. So it is Z1 minus alpha. The value, corresponding value, is 1.645. And if it is two-sided, it means alpha by 2, 5 by 2, 2.5%, or 0.025. And we can write down Z1 minus alpha by 2, its value is 1.96. 1.96 is most popular value, we know. Okay. So two-sided we are using for RCTs, quasi-experimental, case control studies, even equivalence studies. Okay. And one-sided, yesterday I told you that we are using for superiority and non-inferiority trial. Okay. So tomorrow we will use this 1.645 value, but today we will use 1.96, and yesterday we used this 1.96. Okay, Z value. Now This is a formula, Pocock's sample size formula. This formula is called Pocock's sample size calculation formula. Pocock's formula. Okay, Pocock. So Pocock is a famous mathematician. Okay, so he gave this formula to calculate sample size for comparison of two proportion. It may be difficult for you right now, but no problem. We will do step by step, then you will get it, and it will be very easy for you. Okay. So it is called Pocock sample size formula for two proportion, or sample size calculation for comparison between two groups when endpoint or outcome is categorical or qualitative. Okay. Or sample size calculation for RCTs of two groups with categorical or binary outcome. So this is sample size formula. We will discuss one by one. Okay. So come here. It is N2. N2 means there is a group number 2. N2 means this we are calculating sample size for group number 2. Generally, group number 2 is control group. So what we are doing, we are calculating sample size for control group, and generally 99% studies, number of sample size in control group and number of sample size in experiment group or case group is equal. Okay. So if we are calculating sample size for control group, so automatically we can calculate sample size for intervention, because N2 means control group is equal to N1, that is a experimental or case group or intervention. Okay. Then this is formula is R plus 1 divided by R multiply by, okay, Z alpha by 2, yeah, 1 minus alpha by 2. Yesterday I told you that we can write down Z alpha by 2 or 1 minus alpha by 2, okay, plus Z beta or 1 minus beta. Yesterday in both formulas for one group mean or one group proportion, Z beta we did not discuss, okay, did not come Z beta. But today we are comparing two groups, so Z beta is coming here, plus Z beta square, okay, multiply by capital P, this is capital P, and multiply by, in bracket, 1 minus P, okay, divided by P1 minus P2 square. So P1 is, what is P1? Okay, what is R? Please see this here, R, ratio of control to cases or interventions. So control group is N2. So R is N2 divided by N1. And we know generally what we are taking equal number of control and cases. So N2 is equal to N1. So N2 divided by N1 comes 1. Okay. 1/4. So R is equal to 1/4 equal number of control and or case or intervention. Okay. So here when we put R is equal to 1 in this formula, R is equal to 1 plus 1 divided by 1. So 1 plus 1 is equal to 2. So we can directly multiply by 2 here. 2 multiply by this one. Okay, this one. Now P, what is capital P? Here capital P in this formula you can see. Average proportion of the outcome. Average proportion of the outcome. So what do you mean by proportion of outcome in cases or intervention group? P1 plus proportion of outcome in control, that is P2, is divided by 2. So what do you mean by P? Capital P is P1 plus P2 divided by 2. We will do one by one. Okay. So what is capital P? Average of proportion in control and proportion in cases, average. So P1 plus P2 divided by 2. Okay. So suppose at 3 month in control group, mortality is 50%, and intervention group mortality is 20%. So what will be capital P? Can anybody tell me? 50% in control mortality at 3 months and 30% mortality in intervention at 3 months. So what will be capital P? Please tell me. Okay, what do you mean by 40%? Okay. Some are saying 40, some are saying 35. What is 50% in control group mortality at 3 months, 30% in intervention group at 3 months mortality. So what we have to do? 50 plus 30 divided by 2. 50 plus 30, that is 80 divided by 2. It means 40. And 40 we can write down, it is in percentage, so we can write down 0.40. Percentage we can write down 0.40 or 40%. So this will be P. Okay. So what will be 1 minus P? If we calculated P, so what will be 1 minus P here in this formula? 1 minus P. Yes, it's a 60% or 0.6. Very good. And what will be P1 minus P2? Please tell me. P1 minus P2. Oh, 20. Yes. 50 minus P1 is, please you have to see this. What is P1? P1 is intervention group. Cassage means intervention group P1. And control group P2. So P1 is 30 minus 50. 30 minus 50. Yeah, 0.3 minus 0.5. So what comes? Please tell me. 0.3 minus 0.5. And please use minus 0.2. Yes, 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 minus. And when we are doing minus 0.2 square, you can see here it is a square. What will be value of this? Minus 0.2 square. So what will be value? Tell me. Yes, it will become in a plus, because when we are multiplying minus into minus, minus multiply by minus, minus 0.2 multiply by minus 0.2, it will come. You can use your calculator, you can use your phone, okay? Then you can type result here. So it will become 0.04. Yes, yes, yes. So what we have done? We have done excellent things here. Okay. Okay. So we have calculated P1 minus P2. And in proportion or categorical, P1 minus P2 is also called effect size. P1 minus P2 is also called effect size. Okay. In proportion or in categorical qualitative binary outcome, P1 minus P2 is also called effect size. Please remember this. And it is also called difference between two group proportion. Difference of proportion between experiment group and control group, P1 minus P2. It is also called effect size. So can anybody calculate the sample size with 80% power of study and 95% confidence interval? What we have done? We have calculated this R, because there is an equal sample size, so R is equal to 1. So 1 plus 1 divided by 1, it comes 2. Because 1 plus 1 is 2. 2 divided by 1 becomes 2. So 2 multiply by Z alpha by 2. So at 95% confidence interval, what the value of Z alpha by 2? Can anybody tell? 1.96. Very good. Yes, yes. You have to see this table. And I told you that if it is not superiority or non-inferiority, you have to take two-sided alpha by 2 value. That is 1.96. And what will be beta value of power of 80%? Z beta value. Z beta value. What is Z beta at? Yes, yes, yes. Please tell me. What will be Z beta at power of 80%? 0.842. Yes, yes, very good. 0.84. Okay. So I think we have each and everything in this formula. We have this R value. Okay. We have this Z alpha by 2 value 1.96 plus 0.84. That is Z beta plus, and then it is a square. Then multiply by P will be 0.4. Multiply by 1 minus 0.4. It become 0.6. Divided by P1 minus P2. P1 minus P2 square. We have already calculated. It came 0.04. So put these values in sample size calculation formula. So I'm putting all these values in sample size calculation formula and we will do, okay? So see here, step by step we will do. Here, this is, okay? I'm sending this, please. How can I send? I will send it in WhatsApp group, okay? This file I'm sending in WhatsApp group. Please check your WhatsApp group. And please download it. Then we will do. I'm sending it. Okay. Okay. Please download it. And then do step by step. No need to worry. How 0.842? Okay. How? I have to give answer of this how. Because I told you that if it is not non-inferiority trial or superiority trial, it's just RCT or case control study or quasi-experimental study. So this Z beta or Z1 minus beta at 80% power, we have to see this slide. Please see this slide. Okay, here. So it's a power of study, it's a 80% power. You can see here. It's 80% power here. Okay. So at 80% power, corresponding Z value is 0.842. And how it is calculated, then we have to go for it's a base mathematics. Okay. So no need to go, just remember these values. Okay. So when we do this, I have share you the, this is, okay. 2 proportion. So put all these values in this. Here, this is formula. Okay. So here we have done, okay, already I have done here. So P1 is 30% mortality, P2 is 50%. I have written. So capital P is, you can do 40%. Okay. Then Z beta is for 80% power, it is 0.84 or 842. For 90%, it will be 1.28. Okay. And Z alpha by 2 or 1 minus alpha by 2, this is 1 minus alpha by 2 or 1 Z alpha by 2, it is 0.95 at 95% confidence interval. P1 minus P2, that will be effect size. Okay. So this, we have already calculated this. and put all these values in this formula one by one, step by step. Then what you have to calculate? We are getting this N2. It is N2. And we know N2 is equal to N1. Here N2 is equal to N1. So in each group, we have to recruit 95 patients, total 190 patients. And this is sample size calculation formula. We can, interpretation we can write down. In this study, we have calculated the sample size based on the proportion of the patient with stroke developed bed sore, or I can say with stroke proportion of mortality. Here I want to do mortality, okay, of patient with stroke at 3 months. According to previous study, mortality was present in 50% of the patient with stroke 3 months in control group. Reference we have to give here. In current study, we assumed or hypothesized that around 30% or there is 20% absolute reduction. So what do you mean by absolute reduction? There is a 50 minus 20, that is a 30% of the patient with stroke died, because it is a mortality, okay? Died at 3 months in intervention group. So in our study, we have to recruit 95 patients in each group, total itna, to achieve 80% power of study with a 95% confidence interval. We have to mention what power and what confidence interval we have used to calculate sample size. Please remember. And at 10% dropout sample size would be, then this is formula. Then we can calculate formula. There is no problem. And this is, so with 10% dropout, the researcher has to recruit total 212 subjects, or in each group 106 patients. So step by step, we have to do this. Step by step, we have to do. Okay, I have sent this file to you. So it is step-by-step calculation of the sample size for two proportion or quasi-experimental studies, or for RCTs of two group with a categorical outcome. Remember this, it is for categorical outcome. So I hope that you have cleared this thing. If you have any doubt, you can ask me, there is no problem. Yes. Oh, yeah, 2355.3 is the answer. No, I think it's wrong. You have done. Okay. Yes. I cannot share PPT, sorry, but I can share this. It's not answer. I think you have seen this, Renuka. You have seen this step by step, how to calculate. So then you will get it. Please do this. This is formula. We have to put all the values. Then step by step calculate. 1.96 plus 0.84 square, 0.40, 1 minus 0.40, and this is minus 0.20. Then step by step we have calculated, then you will get around this 94.08. So we have to take 95 without any addition, including loss to follow-up or non-response rate. After including non-response rate, 10%, we have to get this. Okay, so this is how to calculate sample size for RCTs of two group, where primary outcome is of type of proportion or categorical or binary in nature. For example, hypertension, yes or no, pain, yes or no, mortality, yes or no, bed sore developed, yes or no, okay, fever developed, yes or no, comorbidity developed, yes or no, any problem developed, yes or no. That is a binary outcome. Then we have to use this, okay? So if you have any question, you can ask me, no problem. Sir, what is the effect size What is the, I have told you for proportion, okay? For proportion of like for proportion or categorical outcome, this will be effect size. Please see this. This will be difference between two proportion. This will be effect size. So this is effect size. Okay. You have to remember. Why do we use two Z values? Why? Why? There is no answer for why. This is a formula to calculate sample size. So we have to use two Z values. One for confidence interval, second for power of study. So we have to use. Please, sir, can you explain again where we have to use this formula? You are doing one study and you want to assess or evaluate the effect of intervention on mortality of the patient at 3 months, on hypertension of the patient in 3 months, or bed sore development of the patient at 3 months, or any qualitative type of outcome, categorical outcome, binary outcome, then use this formula. Okay. So I think yes. Okay, yeah, you got it. Okay. Yes, yes, yes. I might be. So we have done this. Okay. Now today we will discuss. I will show you how to use calculator, sample size calculation calculator online, and we'll use this values and we'll calculate, and some published article in which they have calculated sample size for their research using this two proportion sample size formula. We will do that also. Okay. Now number two. Okay. Now number two here, we are here. This is number two formula. Okay. So this is Pocock's formula, sample size formula for two means. We are comparing now two means. Earlier, we were comparing two proportion or two binary outcome, two frequency. Now we are comparing two means, mean hemoglobin, mean systolic BP in intervention in control, mean depression score, mean creatinine level in CKD patients, intervention and control. Okay. So suppose there are CKD patients. Okay. And we want to see effect of yoga and meditation on creatinine level of among CKD patients. So randomly we are selected two groups. Okay. One group for yoga and meditation for 3 months or 6 months or 1 year, and one group standard care, that is a control group. Okay. Standard therapy. And after 6 months, we want to assess the effect of this yoga and meditation on serum creatinine level among CKD patients. Okay. So we have to use this formula to calculate sample size. We cannot use this formula. This is for two proportion, because we know serum creatinine level is in numerical, quantitative type of. But this formula is for categorical, qualitative or proportion. So here we have to use this formula. It may be looking very complicated formula first time, but don't worry, we will discuss each and everything one by one. Okay. So please see this. It is again N2. N2 means sample size in control group. Please remember this. Okay, I think Chat GPT never tell you this. This sample size is for control group. Okay, so N2 is for control group or is equal to greater than. This is again same value Z alpha by 2 plus Z beta square. You can see in this formula same value here. No need to worry. Okay. Number 2, multiply by sigma 1 square. Sigma 1 means or S1. Sometimes it is like written here S1 square. S1 means your sigma 1 standard deviation group 1 square plus sigma 2 or S2 small s2. Okay. It is standard deviation of group 2 or control group square divided by R. What do you mean by R? I have already explained earlier in last formula. R is a ratio to ratio of control to cassage or intervention. Okay. So generally what we are taking R is equal to 1. Okay. So here if we are taking R is equal to 1, so what will be here? Sigma 1 square plus sigma 2 square. Simple. Mu1 minus mu2. What do you mean by mu1 minus mu2 square? Mu1 means mean of the outcome value in intervention group 1 minus mean of the outcome value in control group square. Mean of the serum creatinine in control group intervention group at 6 months minus mean of the serum creatinine value at 6 months in control group. 1 means intervention, 2 means control. Please remember this square. Okay. So now this is Z beta, Z alpha by 2. I have already explained Z beta and Z alpha by 2. Mu1 means I have already explained you. And researcher can take value from previously published studies. So mu1 and mu2 we have to take from, we can take from previously published studies, pilot studies, our experience, assumptions. Okay. And this is sigma 1 and sigma 2. I have already explained all these formula in this. Sorry. Here you can see here. Sigma 2 expected standard deviation of the outcome in group 2. It may be based on previous published study. Even we can assume it's sigma 1 and sigma 2. Okay. Sometime what happened, please see this, please listen carefully. Sometime what happened, sigma, the researchers, and in some formulas, sigma 1 is equal to sigma 2. So when we are putting here sigma 1 is equal to sigma 2 is like sigma. Okay. So here sigma square plus sigma square. So it will be 2 sigma square. In generally, when we are calculating sample size, so we assume that there is a equal variance. So when equal variance, it means sigma 1 is equal to sigma 2 is equal to sigma. So here sigma square plus sigma square. So sigma square plus sigma square, 2 sigma square. We can write down here. So this 2 here will come here in front of this. So formula will be very simple. I will discuss, no problem. I will discuss each and everything. So this is formula. Okay. So please take one example, that is yoga and meditation and serum creatinine level among CKD patients at 6 months. So please write down mean serum creatinine level group is 3.4. Okay. In CKD patient, yeah, 5.2. Mean CKD level in control group is 5.2. And standard deviation is 2.4 in control group. So mean serum creatinine level is 5.2, standard deviation 2.4. Okay. So I have to write down in chat in control group. In control group, mean CR creatinine level is 5.2 and here SD is equal to 2.4. Okay. In control group. Okay. Yes. In control group means creatinine level 5.2 SD. Oh, no, I'm not moving any slide. Please see this. Please write. Please don't write chat. Please see my message in chat box. Okay, I'm not moving any slide. In intervention group or experiment group, mean creatinine level is 2.6. Okay, and SD is equal to 1.7. Okay, SD is equal to 1.7. So 90% power of study and 95% confidence interval. Please calculate sample size. Okay. And these in intervention and control we are getting from previous studies. Suppose we are getting. So I have write down here. Okay. In control group, this one, and in intervention group, this one. So at 90% power of study and 95% CI, please calculate sample size. Why do we need to calculate sample size if we already have a study with mean and standard deviation? Is it all from pilot studies? If you are not calculating sample size, your project will be rejected. So do you want your project will be rejected from higher authority, from research committee? If you agree, then no need to calculate sample size. Because you have to calculate sample size, number one, and you have to calculate sample size. Okay, and it is all from pilot studies. So what do you mean by it is all from pilot studies? I'm not getting it. I told you that it is from published studies. Okay, again you can ask me questions. So it will be more clear to other participant also. So thanks for this question. Very good question. You can ask more and more. Because we have to calculate sample size for our research study, because consort guidelines, okay, and there are other guidelines, STOP guidelines, and even our like ICMR, WHO, and other ethical committee, they properly need sample size calculation, step by step sample size calculation they need. Why? For the validity and reliability of the study. If you understand the meaning of validity and reliability, then you can understand why the need of calculating sample size. Okay. So it is usually we would like to do a study, a new question, not just repeat a study in our population. Suppose this published article is from China or from USA. Okay, not from here. Then it is the first time for you to do study in India. Suppose one study is published in South India, but you are in North India. The characteristics of population are different from South Indian. So you have to do study in North India. You can take reference from North India, South India, mean and SD or proportion. Then you have to calculate sample size for North India. So we have to do this. And sometime, very good. Usually we would like to do a study, a new question, not just repeat a study in our population. Very good. So sometimes what happened, please listen this carefully. Sometimes what happened, we have only standard care. Okay, we don't have new like therapy or yoga or meditation or new medicine. So what we have to do, our study is published in control group also, okay, but not in intervention group. So first time we are calculating, we don't have mean and SD for intervention group, but we have mean and SD for standard group or control group. So for intervention group, we can assume, we can take on the basis of our clinical experience. We can assume for intervention group and we have to calculate sample size. Okay. So when we are taking all these value, I think Sujata, you have got this answer. And still, if you have any problem, you can WhatsApp me. I will explain you more and more about. Okay. So we are calculating sample size on the basis of this. Okay, on the basis of this. Okay. So please see this. Sorry. Sorry. Okay. So here this is 2 mean. Okay. So please see this. This is 2 means. This is formula for 2 means, if you remember. Okay. So here R is 1. Generally, we are taking R is 1. And Z beta is I have already explained, and at 90% power, it is 1.28. This is formula. I'm sharing this. I'm sharing this for your reference. Sorry. This is quantitative. Okay. I'm sharing on WhatsApp number. Where is? You can do this. Sorry. Okay. So please use this. Please download this and use this, and we will do one by one. Okay. This is Z alpha by 2. It is at 95%, 1.96. So suppose if you are thinking, why I am taking always 95%, I want to take 99%. Okay. Suppose you think that confidence interval, I want to increase my confidence interval or confidence level, I want to increase. I will take 99% confidence interval. So what will be Z value of 99% CI? What will be Z value? So no need to worry. Go to AI, ChatGPT, or go to Google and type what is Z value at 99% confidence interval. Just write down here. You will get your answer. Okay. Value of Z alpha at 99% CI. You will get your answer. No problem. You will get it will be 2.756. 2.576. So you have to mention this value or 2.58 in round figure. So you have ChatGPT. But main thing is you have to understand all these things. Then you can manipulate all these things. There is no problem. Okay. So here because I told you that generally we are taking 95% confidence interval. Why? Because we are taking p value 0.05. So we are taking 95% confidence interval. Sorry, this is, I think, here I have to take this. Yes, this, okay? This is for N2 and I have explained you N2. So I have given each and everything. Mu1, expected mean of the outcome in group 1. Group 1, what will be value? Can anybody tell me what is value in mu1? Please type here. I have told you. mu1, 2.6. Okay. So write down here 2.6. Sorry. Yes, mu1 means intervention. Please remember, 1 take intervention, 2 take control. This is simple. Renuka, it is 1.7. How it is 1.7? Please see, I have already mentioned in this chat box mu1, mean in intervention, mean creatinine level in intervention. I have mentioned here 2.6 here, and SD means sigma or S 1.7. Okay, I have mentioned over there, no problem. So what I have to do? I have to mention here. Where is here? So what will be? It is 2.6. Oh, sorry, 2.6 here. Sorry. Here. So I'm also doing mistakes. Here I have mentioned 5.2, I think. Expected mean of the outcome in group 2 or control. I think it is a 5.2. And here sigma 1 or S1. I told you it is sometimes we are saying it sigma 1 or sometimes we are saying it S1. S1 means small s. Small s means standard deviation of the sample. Group 1, what is the value of 1.7? And in group 2, please tell me, I forgot. Can anybody tell me SD in group 2? 2.4. Yes, 2.4. Okay, thank you. So what we are doing? 2 point here. 2.4. So mention all these things in this formula. No need to worry. Step by step, please do this. Step by step. Sigma 1, 1.7. Sigma 2, 2.4. Mu1, 2.7, I think. And mu2, 5.2. If I am wrong in anything in entering, please, 2.6 here. Please see this. It is 2.6 here, mu1. So 2.6 I have to fill here. Where I have to pull? 2.6. I think it is okay. Then what we have to do? We have to calculate this. Please add this and this. You will get this 3.24. And please do 1.7 multiply by 1.7. Please write down here. Please give me answer. 1.7 multiply by 1.7 because it is written 2.89. 1.7 multiply by 1.7, 2.89. Okay. 1.7 multiply by 1.7, 2.89. 2.4 multiply by 2.4 because it is a square. So I'm telling, take it square of 2.4. Please tell me value of this. Step by step we will do. 5.76. Okay, very good. So please fill it here. 5.76. No need to worry. 5.76. And please take it here. I think it's a. And please don't forget sign. It will be minus 2.6, I think. Please never forget sign. Yes, minus 2.6. Very good. Pooja Keval, very good. So it is. Then please do this. It's a 10.50. It's plus, please calculate this. 2.89 plus 5.76. Add this and tell me value of this. We are calculating sample size step by step. 14. Yeah. 8.65. Okay. 8.65. Yes. Okay. Very good. So I'm writing here 8.65. 8.65. Okay. Minus 2.6. Minus 2.6. Minus 2 point square. Please tell me. Minus 2.6 square. 7.65. Okay. Very good. So please write down 7.65. 7.65. Very good. Then calculate this and this. Please tell me. 10.50 multiplied by 8.56. Please tell me the value of this. You are doing. I am just filling. 6.76 is denominator. Very good. Please tell me numerator. 90.9. Okay. 89.88. What is the mistake here? 90.9 and 90.82. Why? Okay, there is some might be main points here. Up to 2 decimal. Up to 2 decimal in round. Up to 2 decimal. Please tell me. Okay. So here in denominator. Okay, denominator we will do. There is no problem. 90.82. Numerator is 90.82. Okay, numerator is 90.82. Sorry. Numerator is 90.82. 90.82. Denominator, you have told me. Denominator 7.6, I think. Say 6.76. Okay, 6.76. Very good. Here 6.76. Here 6.76. So what will be value of this? Tell me here. 13.44. Okay, very good. 13.44. So no problem. So it will be 13.44 to take round. 14 you have to take, not 13. 14. Okay. So here N2 is 14. Here N2 is N1. So we in recruit 14 patient in each group. So total 28 patients. You can take 15 also. There is no problem here. You can take 15. But we are also calculating loss to follow up. So use this this exact value 14 or 28. Then in loss to follow up adding, you can round figure. So sample size for the study was calculated based on the Mohammed et al. Study. Suppose this is a reference. We have to give this reference. According to alpha 5% and power of study 9, and using the pre-test and post-test means and standard deviation of the, here we have to do deviation of mean deviation of serum creatinine level in the study of Mohammed et al. So what is here? What we have to write down? It is 5.4. Sorry. It is, I think we have written 5.4. And what will be standard deviation? 2.4. And in intervention group, it is 2. I forgot, I think. It is 2.6. It is 5.2. You can see and you can write down. There is 2.6 plus minus 1.7. Okay, respectively. You have to write down here milligram per DL. Please never forget it. You have to write down unit. Never forget to this. The minimum sample is set to 28. 28. This is time. Subjects 4 and total 28. To increase power, and please see this. We can write down according to this. To increase power and considering the possibility of loss to follow, that number will raise to, we can write down here, it is total 30. Sorry, 15 subjects in each group. Or even we can take 20 also. No problem. If there is a feasibility of the participants, we can take 20 subjects in each group. Because this, if we increase sample size, it will increase our power. Okay. It will increase our validity and reliability also. So we can take according to this. Okay. So otherwise we can write down this. Remove this line. We can write down this. Anticipating 15% loss to follow up, we have to recruit 20 participants in each group. Total 40 participants. We can add this instead of this. Otherwise, we can write down according to this. It is also valid. So step by step, we have to do. All the things are hypothetical, okay? But we have to calculate sample size. So if you have any answer, you can. SD is more than half of the mean. Yes, there is no problem. No issue. Okay. For sample size calculation, it's okay, no problem. I have sent in WhatsApp group. Or this edited file I have to send, please tell me. Mega Mata, please tell me. How to loss to follow-up can be more than 10? Yes, it can be up to 30%, no problem. It can be 30%. Surbhi Bhargava, it can be 30%. There is no problem. Attrition of 10%, it will be 16. Yes, you can take attrition of 10%, 5% on the basis of your clinical experience. You have vast clinical experience and you know how many loss to patient in 6 months. So this is step-by-step calculation of the sample size. Yes, edited file I can send you. There is no problem. So what you have to do? You have to do practice. But before practice, you have to understand each and everything. Then you can do practice. Oh, I have to save it. Then I have to send you this file. Okay. No issue. This is edited file. Now we'll do some online software. How to calculate sample size in online software using these examples. So first software is where is my slide? Yeah, OpenAPI. Number 2, Statulator. Number 3, CleanCalc. Okay. So CleanCalc we will do. First we will do CleanCalc. Okay. So what we have to do? Just type here in your Google. Please do this side by side. Okay, I will add you. There is no problem. Please send me message. 30-30 ratio of sample size in each group. 30-30 ratio. Yes, no problem. Sir, what if we have no study available? Then how can we calculate sample size? Your clinical experience, your assumption, you can do sample size calculation if you don't have. Okay. If we have 3 group, 2 intervention, 1 control, the ratio of participant is 2 to 1. How we change the calculation? Yeah. it will be some difficult scenario. And in this workshop, we did not add this more than 2 group, but no problem. I will send you file in group WhatsApp group. You can go through how to calculate sample size for more than 2 group. And if you have any question, you can ask me in my personal WhatsApp number. You can ask me, okay? So I will send you edited file or Word file. So, okay, just click here, which clean calc, clean calc here, clean calc sample size calculator. Please click this. We will have some hands-on practice. This is clean calc sample size calculator. Please see this. We will do step by step all the things. Please click this. This is sample size calculation. Okay. So we have how many group we have? We have 2 independent study group. Please click this. Okay. Please no need to click this because it is only for one study group and versus population. But we have 2 independent study group. So please click this. If you click this, it will come up like this. So please click this because we have 2 independent group. Okay. Now here our primary endpoint or primary outcome is dichotomous or continuous. I have explained you very well. So please tell me if my primary endpoint or primary outcome is pain at 2 hours, yes or no, present or absent, pain at 2 hours after post surgery, present or absent. So which type of my primary outcome? It is dichotomous or it is continuous? Please tell me. Dichotomous. Yes. Very good. So you are getting. Very good. Binary. Very good. Okay. Binary. Very good. Dichotomous. So now we are very clear about what do you mean by when we have to go for mean and comparison of the two means, and when we have to choose the formula for comparison of two proportion. Okay, very good. So here, I think this is yes. I'm taking this. So this is about mortality at 3 months. Okay, this is because this formula is for proportion. So I have to click OK. This is selected dichotomous. Now, please see this. Its parameter here. Anticipated incidence group 1 and group 2. Please tell me what will be anticipated incidence in group 1 mortality. It is 30%. And what is in group 2? That is a control group. It was 50%. Alpha is 0.05. If we remember this 5% alpha value, that is 0.05. And power we have selected 80. If I want to make it 90, please drag it. It will be 90. But here I am taking it 80%. Never use power less than 80. Please remember this. Never use power less than 80. Enrollment ratio, control to cases, it is 1. R is equal to 1. Here. Then calculate sample size. No need to do anything. Just click calculate. And this will be result. I don't know. It is coming 93 in control, intervention group 1, and 93 in control. So what was our result? We can match it, no problem. Okay, we can match it. Okay, we can match it. Here, in this we can match it. Sorry. Here we can match it. It's coming 95. It's coming 95 or 94.08, 95. So it is coming 93. Okay, so almost equal. Sometimes it may be some 1, 2, 3 less sample size, or sometimes it is greater than when what we have calculated. So it means it is okay. It's okay. It's fine. There is no problem. And after that, you have to mention this from where you have calculated sample size. Calculated sample size using clinicalc.com online calculator. You have to mention here. You have to mention here. Okay, you have to mention here and there before this. Sample size was calculated using this software. You have to mention here. Okay, so if anybody want to recheck this, same result will come. Okay, so there is no problem, because nowadays sample size calculation is rechecked again and again. So you have to mention each and everything. Got it? Yes, you can mention, no problem. Does the general accept this online calculator? Oh, yes, easily, there is no problem. Easily. It's a very famous calculator, reliable calculator. Okay? Now, go to this. There are two independent group, then continuous mean. So what is R? This is for this one, mean. Okay, I have to click this. Then this is formula. Please calculate for this. So here, where is here? Click this continuous. When we click this continuous, below things will be changed. But please remember here. There is some trick in ClinicCalc. Group 1, they have given mean here plus minus SD. They have given. But for group 2, they have given only mean, not SD. In this case, this calculator assumed that standard deviation is similar in group 2 also. So what standard deviation we entered in group 1, they assumed same standard deviation for group 2 also. Okay, so this is some tricky here. And what the power of the study? Because L5 0.05, power of study we have chosen 90%, so just drag it 90%. Then we have calculating for mean, enrollment ratio is 1. So please fill it. Because we are using group 1 SD for group 2. So sample size, what we have calculated is some different. Okay. So please remember this. So what we have to do, we have to fill here. Group 1, 2.6 and SD 1.7. And group 2 mean 5.2, I think. And SD we have taken 2.4, something like that. But here we cannot take. There is no option here. Ideally, it should be here plus minus SD for group 2 also. But here it is not. But if you are calculating sample size according to this, it is also valid. Because you are mentioning over there, we have calculated sample size using ClinicCalc. So it is also acceptable by the journal also. So just click calculate, you will get sample size. Okay, so this is sample size 9 and 9. Because we have, it is lesser than our calculating sample size 9 in group 1, 9 in group 2 and total 18. Why? Because we have taken this 1.7 standard deviation for group 2 also. So is there any other software in which we can use this mean and plus minus SD for group 2 also? So there is another software. Just click here, Open API. Open EPI. Just click open EPI sample size calculation. Okay, just click this open EPI. This is open EPI sample size for this. Click this. This is sample size calculation. If you have any problem, sir, if we do it by manually, it is more reliable. Yes, it is more reliable. Yes, very good. If it is we do by manually, it is more reliable. Always it is more reliable than using using these online calculator. Okay, very good question. And for manual calculation, how to do manual calculation, this workshop is organizing step by step. Sir, for dichotomous clinical with decrease or increase, what do we feel in both? Okay, so for dichotomous in decrease and increase, suppose 50% motility group 2, yeah, control group at 3 months, and we want 20% decrease in group 1, that is the intervention group. So we have to mention we have to click decrease and we have to mention 20%. So, okay, go to over there in clinical, in dichotomous. Here it is incidence. So here it is a decrease. So decrease by here in here what we have to do? We have to write down here in group 1 50% and decrease in group 2 by 20%. Okay, then we have to calculate sample size. Then this is coming according to this 20% decrease. Okay, 1 minute. This is 20% percentage decrease. Okay, this is percentage. So what is tell me, sorry, what will be? It is a percentage decrease. So if I want this from 50 to 30, 15, suppose in control group it is 50, and in intervention group it is 30%. So can anybody tell me what will be percentage decrease if we want 30%? So I think it is around 40% decrease. Okay, then calculate sample size. Yes, then make it 80%, then calculate sample size. It will be equal 93, 93. Earlier it was 93, 93. So I think you are getting this. What? Because we have see this. So it is some complicated thing. I think I'm not here. You have to see this. Here, where? No, it is not. Yeah, this one. Yes, very good. Where? Here. Okay. This is 20% absolute decrease. Okay. Here I have written here. It is absolute. But in this formula, it is not absolute decrease. It is this 20% is not absolute decrease. It is relative decrease. What do you mean by relative decrease? 20% absolute means 50 minus 20, that is 30%. But if I say it is a relative difference, relative reduction. So what do you mean by relative reduction? Relative reduction. It's a 20% relative reduction. It means 20% of 50%. So 20% of 50%, what will be? It came, if you are getting this, it is very, it is necessary to make difference between absolute reduction and relative reduction. So please see this. If it is absolute reduction of 20%, it means in group 1, if it is 50%, or absolute reduction means minus 20%. So what will be value? It is coming 30%. Okay. But if it is write down here, relative reduction of 20%. So what do you mean by this? Relative reduction of 20%. It means 20% of 50%. So can anybody tell me what will be value of 20% or 50%? If you have some mathematical idea, can anybody tell me? 10, very good, 10. Okay, very good. So what we have to do? We have to write down here 50% minus 10%. So it will be 40%. So if you are taking absolute reduction of 20%, the result is 30%. And if you are taking relative reduction of 20%, the result is will be 40%. So this is a difference of relative reduction or absolute reduction. Okay. So here what is we have to take, because we have taken 20% absolute reduction and we have calculate. So answer will be 30%. Okay. So how can be answer is 30% here in case of relative? Because here in Kilcal it is a relative reduction, not a percentage decrease in means relative decrease. Okay. So here in relative reduction of what will, how can be it 30%? So 30% we have to make it 20%. So relative reduction, this value, what will be this value? The answer will be 20%. Okay. So it will be, can anybody tell me what will be value of here? Then answer will be 20%. So here we have to write down 40%. So here 40% answer. So relative reduction of 40%, you can check it here. So 40% or 50%, what will be? 20%. So here 20% relative reduction. Okay. So this is relative reduction is 40%. Absolute reduction is 20%. So this is coming according to this. I will give another answer. There is no problem. So they answer the sample size calculation result almost similar. What we have calculated for when we use this only incidence of 30%. Okay. Then it will be also 93. It is also 93. Okay. So there is some we have to understand about this. Now open API. Okay. I'm going to open API. In open API, please see this is a sample size calculation here. In the left side, you can see, click this sample size. Click this mean difference. Here mean difference. Okay. Click this mean difference. Then click this enter new data. Okay. This software is also reliable. So here we have written down confidence interval, two-sided 95%. Power we have taken 80% or 90%. So in this case, we have taken 90% if you remember. Ratio of sample size group 2, group 1, we have taken 1. Then here group 1 mean and SD we can enter, and group 2 mean and SD we can enter. Okay. So here mean in group 1, I think it is 2.6, 1.7 SD. Here 5.2 and 2.4. If I remember, just fill these values in this. Okay. Then click calculate. I think I'm right for this. Yes, I can check this. 1.7, 2.4, 1.7, 2.4, 2.6, 5.2, 2.6, 5.2. Yes. Then click OK. Calculate. This is coming sample size. Sample size for group 1, sample size for group 2, and total sample size 28. What we have calculated manually. If you remember, what we have calculated manually. So here we have calculated manually 14. So it is coming exact 14, 14. And you can give this reference also. Here this is a reference for this. Okay. Open API version 3. This is you can take. So this is Open API reference 14 and 14, 28. Manually we have. In clinical, you have seen that there is no option for SD for second group. Only one SD we can enter. But in Open API, we can enter standard deviation for both group and exact sample size came. What we have done manually. Okay. Then, sir was unable to understand this. Dilpreet Kaur, what you have unable to understand? Sir, group 1 will be control or intervention. Generally, what I'm recommending, I'm taking always group 1 as a intervention. But if you want to take a group 1 as a control, you can take, there is no problem. It is a mathematics. Okay. So sample size calculation will be exact. There is no problem. Absolute reduction and relative reduction. Okay. I will explain you again with a simple example. Okay, I'm opening this file. Yeah. Here. Suppose my value is 10. Okay. Here I want to get absolute reduction of 2. So what will be answer? Can anybody tell me what will be answer for absolute reduction of 2? Can anybody tell me? Yes, 8. Very good. It's a very simple. Okay. Yes, it's a absolute reduction. So minus 2 is giving 8. Suppose if I'm taking in the place of absolute reduction, I'm taking relative reduction. Relative reduction of 2. Okay. So generally what this is absolute reduction. Okay. So absolute and reduction and relative reduction, generally it is coming in for like 10. Okay. So for relative reduction, we have to take here relative reduction of 2. So what will be relative reduction of 2? We have to take from this 2, 10, from this 10, this value. Okay. So what will be value of relative reduction of 2? Please see this. We have to do 2 by 10. So it is coming 0.2. This is meaning of relative reduction. Absolute reduction, and then we have to relative reduction of 2, and this relative reduction of 2 out of 10. Please remember this. So the answer will be 10 minus 0.2. This time it is not minus 2. This answer is 9.8. This is meaning of relative reduction. You have to get this relative reduction of 2 from 10. Okay. Then you have to 2 by 10 is equal to 0.2. Then this will be your, now this will be your absolute reduction. So relative reduction of 2 out of 10 will be your 0.2 absolute reduction. So this will be answer. Okay. Again, take any example. Suppose answer is, for example, it is 40. Okay. Now, absolute reduction is, suppose, 10. So what will be answer? 40 minus 10 is equal to 30. But here, if I write down relative reduction of 10, relative reduction of 10, so relative reduction of 10 out of 40. So what will be here? What I have to do? I have to write down 10 by 40. So what will be answer? What will be answer? Please give me. And then what will be answer? Can anybody tell me? 0.25. Yes. So this will be here 0.25. So this is meaning of relative reduction and absolute reduction. Okay. So what will be answer? 40 minus 0.25. It will be answer 39.7. So absolute reduction you can directly get 40 minus 10. But if you are getting relative reduction is 10, then you have to do. So suppose if it is a relative reduction of 50, it means, what do you mean by? 1 minute, 1 minute, 1 minute. It may be some mistake here. Please hold on. Sorry. Suppose it is a relative reduction of 50, then we have to take it's a 50%. Okay? 50%. Relative reduction of 50 of 40. So please hold on. So it means relative reduction is 50, suppose. So it means 50% of 40. Yes, yes. So what will be 50% of 40? 50% of 40. Please see this. It is accurate. It will be 20. So what will be our answer? 40 minus 20 is equal to 20. Otherwise, okay, otherwise if we take absolute reduction is 50, suppose it is 50, absolute reduction. So what will be answer? 50 here. So what will be answer? Minus 10. But if we take relative reduction is 50, then this will be answer. We have to take relative reduction, we have to take percentage. Okay? So this is correct. So what we have to do? We have to get a relative reduction of 2. So it means we are getting relative reduction of 2. It means 2 relative reduction of 2% or 2% we have to take. Then we have to calculate it. Okay. So this is coming, relative reduction is coming in larger value sometimes. So it is not coming 2. It is coming around relative reduction of 50% of 10. This is coming. So relative reduction of 50% of 10, what will be here? It is coming 50 divided by 100 multiply by 10. This will be answer. So 50% of 10, it will be 5 answer. Okay. So this is, then I have to write down 5 here. Then this will be answer 5. So this is actual value 10, absolute reduction of 2. So it is coming 10 minus 2 is equal to 8. And if you are taking here, suppose relative reduction of 50% of 10. Okay, 50%. It is only 2 and it is coming 50. Sometimes it is not given here, only it is given relative reduction of 50 of 10. So we have to think that it is a percentage of 10, 50% of 10. Okay, so 50 by 100 into 10, we have to calculate relative reduction according to this. So relative reduction is, we have to use in percentage, not in absolute values. So this is calculating of relative reduction. This is formula. So if I am saying that a relative reduction of 30% of 20, yeah, 30, relative reduction of 30, okay, 30 of 20. Actual value is 20, but it is a relative reduction of 30. So what I have to do? I have to write down here 30, 100 multiply by 2. So what will be answer? I have to write down. It is coming, I think, around 6. So relative reduction, otherwise it is absolute reduction. How can I get a 6? I have to write down 4 here. Then I can get 6 here. So this is some like how to get absolute reduction or relative reduction. Okay. So if you have any answer, you can ask me. Yes. Yes. So you have to think about this. Okay. Very good. Yes. Then we have done this. Open API we have used. Okay. I think I have some time. Yes, I have some time. So I'm taking some published articles, how to calculate sample size. So here, comparison of two proportion. Please see this. Here. Okay. So this is published study. Effect of sphenopalatine ganglion block on post-craniotomy pain management, a randomized double-blind clinical trial. This is published in Neurological Focus Journal, okay, in 2023. So here they have given sample size calculation. So we will do sample size calculation. We will verify it, whether they have done correct or not. So this is, sorry. Please see this and calculate sample size using formula or even calculator. Yes, this is. According to available incidence, please see how we can write down sample size calculation sentence, statement, paragraph. According to available evidence, the incidence of moderate to severe post-craniotomy headache is 60%. And they have given this reference. You can see here. They have given this reference 2 number. Because according to previous study, available evidence, the incidence of moderate to severe post-craniotomy headache is 60%. So can tell me the primary outcome of this study, and it is of proportion type or mean type primary outcome. Please tell me. Based on this data and assuming a 50% reduction in the incidence of the main outcome. So what is main outcome in patients undergoing SPGB compared with standard treatment? So here standard treatment means our control group. And in control group, what is the incidence of moderate to severe post-craniotomy headache? Please tell me. And after that, tell me in intervention group. Intervention group is SPGB. That is SPGB is intervention. When we study this go through this study, then we can get the full form of SPGB. Post-ganglionic, something like block, something like that. Okay, I think. Ganglionic block. And a two-sided tailed alpha value and at least 41 patients per arm, 82 in total, were needed to achieve 80% power of statistical power in an intention to treat analysis. So can anybody tell me which formula we should use and they have used to calculate sample size? Can anybody tell me? What is primary outcome? Yes, it is proportion. Very good. Superiority trial? No, they did not mention here superiority trial. Open, oh, no problem. I will open. I will explain open API. There is no problem. Third calculator, tomorrow I will explain third calculator. Okay? No issue. Proportion time. And primary, like headache, incidence of headache is primary outcome. Very good. And this is a 60%. Okay? Yes, this is SPGB block. It's an intervention. Okay, very good. And what is 30%? I'm not getting 30%. Surbhi Bhargava, what do you mean by 30%? Please tell me. It is very good figure, but what is it? Please tell me. What is 30%? Yes, relative incidence. Very good. Very good. Very good. So how you calculated? Here, please see this. A 50% reduction in the incidence of main outcome in patients undergoing SPGB. SPGB means our intervention group. So what they are telling, in SPGB intervention group, there is a 50% relative reduction. They did not mention here relative reduction. They did not mention here relative reduction. Okay? But they have written here a 50% reduction in the incidence of main outcome. So, okay, we are going to do with open API. Okay? Your clinic calc, okay, yeah. Then open API, no issue. So here, clinic calc. So what will be our two group dichotomous? So in group 1, what will be incidence? It is 60%. There is no problem. And what will be incidence here? It is, if we take 50%, if we assume that it is a 50% of absolute reduction. Okay? So what will be value of group 2 here? If we assume that this 50% is absolute reduction, so what will be value of group 2? Please tell me. 10. No, absolute reduction. 50% is absolute reduction. We are not taking relative reduction. Suppose we are, okay, because there is no written over there. It is a relative reduction or it is a absolute reduction. So we assume that it is an absolute reduction. So what will be value of group 2? No, mostly we did not take, we can take relative, we can take absolute, there is no problem. Okay. So it is 10. Okay. So if we think it is a relative reduction, absolute reduction, if you think it, I will explain you again. Sorry. I think there is a problem. Where is where? Here. Okay. Here. Okay. Here. Okay. Here. I'm going to explain you. Suppose if we think that it is in group 1, suppose in group 1, that is a control group. This time we have taken, because we are calculating sample size using ClinicCalc online software. So it is a control group. Okay. So here it is written here 60%. Then they have written there is a decrease in, you can see here, there is a 50%, they are assuming a 50% reduction in the incidence of main outcome. Suppose it is, we think it is a absolute reduction. So what will be value? I'm not getting very. I think I'm not getting here. Yeah, here. Here. So suppose if it is absolute reduction, so in group 2, it will be, it is an intervention group, SPGB group. SPGB group. So here in this, incidence of headache will be 60 minus 50 is equal to 10%. Suppose it is. Okay? We have think this 60 minus 50, absolute reduction. Then check with your this calculator. Click here 10. Group 2, incidence of headache will be 10. Then they have taken for this and 80%. Then click. The answer will be 13 in each group. Okay. So this is if they have taken absolute reduction. But what they have mentioned, what will be value of this? Where is, sorry. Here, this is, okay. Yeah, here they have mentioned 41 patients per arm. And what we are getting only minimum 13 patients in each arm. It means this is not absolute reduction. They have taken as a relative reduction. So 50% of 60%, what will be answer? 50% of 60%. Please tell me. 30. Yes. Yes, very good. So this is meaning of relative reduction. Okay, very good. So now enter here up. Now enter 30% here. Then click calculate. Then we can assume 42 in each of 84. Okay. So our answer is coming 41. So it is like approximately same thing. 41, 82 at 80%. So how can we check this according to this? Okay, if you have any question, you can ask me. The difference of absolute reduction and relative reduction. This is a very good example. So this is about two sample proportion. Okay. Now one paper I will show you how to calculate sample size for mean, comparison of mean. Okay. So okay, comparison of mean. This is comparison to mean sample size. Here, I want to take this example. Let's see this. Okay, I think. Yes, this one. Only 10 minutes are left and we will finish with 10 minutes. There is no problem. So this is, please see this. Effect of mobile-based self-management application on stroke outcome. A study protocol for triple-blinded randomized control trial. So I think you know about what you mean by triple blind. Okay. So then we have to, it is published in BMC Medical Informatics and Decision Making Journal in 2022. And here they have mentioned, where is, here, they have mentioned formula for sample size calculation. They have given step by step, you can see here. Okay, so just please see this. This is formula they have used. Please see this. The formula n is equal to z1 minus alpha by 2 plus z1 minus beta square multiply by sigma 1 square plus sigma 2 square. They did not give r divided by r because they assume that in like sample size in both group is same, equal, divided by x1 square minus x2 square. Okay, x1 sorry, x bar x1 bar minus x2 bar square. What do you mean by x1 bar? This is a mu1. What do you mean by x bar 2? It's a mean of group 2. We have written mu2 square. Okay? With the reliability of 95%. So what do you mean by here reliability of 95%? That is a confidence interval. And the test power is 90%. They have taken based on the mean and standard deviation of the baseline NIHSS. NIHSS is a score, is a tool to assess the severity of the stroke patient. National Institute of Health stroke scale, like depression scale, like anxiety scale, like GCS scale. This is also scale. And we calculate mean and SD for this. On this, obtained in the same study, 29, they have given reference. Z1 minus alpha by 2, 1.96, they have given. Z1 minus beta, they have given 1.282. Sigma 1 and sigma 2, they have given 8. Equal. Sigma 1 and sigma 2, that is equal 8. X1 bar 5, X2 bar 12. So please calculate, please verify the sample size. So which software we should use? We can use OpenAPI because one participant requested me to use to explain about what I have to do. Yes. So here OpenAPI, please see this. Here this is OpenAPI. Click this mean difference here, right side. Please click this mean difference. Okay. Then here, please click enter new data. Here they have used power 90%. Mean group 1. So where is mean group 1? Okay, where is group 1 mean is 5, group 2 mean is 12. They have given here. So 5 and 12. Okay. So I have to write down 5 and here 12. And they have standard deviation equal 8 and also here 8. If you have any problem, just ask me. I have filled right value or not. Sigma 1 and sigma 2 equal 8. Both are equal. Okay, here. Then calculate sample size. Just click OK. 95, 90, ratio is 1, 1. Okay, then calculate sample size. This is coming 28, 28, 56. So what they have written? Please see. They have written was calculated as 27 patients, almost similar, which increased to 30 patients according to the availability facilities with a 10% sample dropout will increase to 33%. And according to two group, each including 33 patients, intervention control with stroke, total patients 66, who met the inclusion criteria will be selected. You can see here each and everything. If you have any confusion, you can ask me. We can take 10% sample dropout, we can take 15%, we can take 20%, there is no problem. So this is here. And in clinic calc, okay, only 5 minutes are left. I'm showing with clinic calc, sample size calculator. In this, it is a continuous type. Okay. Just click this continuous. Here, because we have written here, what is it? Sorry, what will be 5 or 12 and sigma 1 and sigma 2 is 8. 5 and 12. Okay. So you click here 5 plus minus 8. And here 12. And because it is equal, 8 is equal, so we can use this clinic calc. Because in group 2, SD is not given here, plus minus SD not given. But they have taken equal. So in clinic calc, it is like assumption that group 1 SD is equal to group 2 SD. So this is given in this paper. Then at 90%, so select 90, this is 90. Then click calculate. This will be answer. 27, 27, 54. I think they have used this clinical software to calculate sample size, but they did not mention here. So this is 27, 27, 54. And we have already calculated 27, 27. So this is, but you have to give, you have to like write down this from previous study you have taken. This is 29. Reference they have given. So please don't forget. And it is better to include, give reference from previous study. So this is all about how to calculate sample size for two group. Okay. Now power of study. In 1-2 minutes, I have to show power of study. How to calculate power of study. Okay. So from sample size here it is for clincalc.com. There is in right side, there is a post hoc power calculation. It means we have not calculated sample size priorly. We have conducted study, we have analyzed the data, and we sent our data paper for publication. And there is one review question. You did not calculate the sample size priorly before starting the study. So please calculate post hoc power for this result. We have result for like group 1 and group 2. And for post hoc power calculation, we have to click this post hoc. How to calculate? Please see this. Click here. So this is coming to independent group because there are two independent group. Our primary outcome is dichotomous, okay, or even continuous. There is no problem. So dichotomous, click this. Then here, our study incidence. Suppose we have conducted study and we got our result. Development of bed sore in group 1, that is an intervention group, is 27.4%. And in group 2, it is 52.3% in our study result. Okay. And in group 1, we have recruited 50%. And in group 2, we have recruited 50%. Okay. Alpha value is 5%. Here what we are giving? We are giving here number of subjects here. Okay. Earlier we are calculating this number of subjects, but in post hoc power calculation, we are giving these results of our study, not a previous study, of current study, and we have recruited this much patient arbitrarily. We did not calculate, we just recruited, and then calculate power. So just click calculate, you will get this power of study. And please remember, your power of study never be less than 80%. So it is less than 80%. So the reliability of the or validity of the study, and there is a less chance of publication acceptance if your power of study is less than 80%. So this is how to calculate post hoc power calculation for two group when you have dichotomous outcome, when you have continuous. So please click this continuous and then please see this group 1. You can see here group 1 mean and SD, group 2 mean and SD. So suppose I got serum creatinine level at 6 months value in group 1, that is 2.6 and SD 1.7. And in group 2, it is 5.4 and SD 2.4. Suppose these are my result. And I have recruited around 20 patients. Okay. I have recruited 20 patients for this. Suppose this is a hypothetical, but it is a my study. Okay. Then calculate power of study. So what will be power of study? It is 98.9% power of study. It is called post hoc power calculation. So more chance of acceptance of this study, reliability of this study. Okay, thank you. If you have any question, you can ask me, no problem. Go to sample size, okay. Open API I have done, I think. Can we do observational study? For observational study, there is no power. No need to do power. It's just observation study. So if there are two group and you are comparing two group, then you can calculate power, cost of power. There is no problem. Yes, you can mention it is less than 80%. There is no problem. You have to mention. Unable to get two group in app. Two group for mean. Open API, how to get two group in Open API? Okay, there is Open API. Please see this, no issue. Here, this is Open API. Here, this is in left side, there is a sample size. Click this sample size here. You may get this. Okay, click this sample size, then click this mean difference here. When you click this mean difference, please see my, yes, here. Or otherwise, you can just click this enter here. Mean difference, then click enter. You will get this here. Click enter. Then you will get group 1, group 2 like this. Okay. Mean difference. Okay. Then click enter. You will get this. Enter. You have to click enter. Then you will get. Okay. Then you can. Okay. If you have any, again, if you have, yes. Okay. I think now you go. We got it. Can we use post hoc for convenience? If you have two group, then you can use, there is no problem. Okay, sir, what if the median and IQ are reported instead of mean and SD? What will be the formula? Formula is same, but what you have to do? You have to convert this median and IQR in mean and SD using that link. So this is link, okay? See this? This is link, yeah, here. Please see this. This is link. So from, okay, this is, I think, another link. Yesterday I have sent you link. Okay, I'm using this link. 1 minute. I'm checking this link. I'm setting this link of this link. Okay. Then, yes, from here we can like calculate our here mean value if available, first quartile if available, median value if available, third quartile if available, maximum value if available, sample size, number of bootstrap, we can say 1000. This is quantile estimation QE. It is okay. There is no problem. Then we have to click. Suppose our first quartile is 12.4. Median is, suppose median is 15.3, yeah, 15.6. Third quartile is 20.4. Okay. Then our sample size is 100. Okay. Then you can see answer. This is, you can get answer of this. Estimated mean is 16.94. Estimated standard deviation is 6.56. You should use these mean and standard deviation, and then formula is same. Okay. So you can do this. Otherwise, yesterday I have sent the link of another software. You can use that software. This is also software you can use. Online software, online calculator you can use. Okay. So I can send you this software text. You can use, no problem. So if you have any, yesterday, tomorrow I will send, or in WhatsApp I will send you. Okay, there is no problem. Purpose of post hoc analysis, because without calculating sample size, you are sending your paper for publication. So there should be some reliability or validity. So for this, we have to do post hoc analysis. Okay. So this is the purpose of post hoc analysis. So if you have, for two study group, we have median IQR. Okay, I have told. What is variance? Oh, variance is simple. Square of standard deviation. Resu, that is, okay. Square of standard deviation, that is variance. It is very simple. Okay. So I think we should stop our class here. If you have any, please share updated file of R formula used. Okay, no problem. Here do we have to mention one group or combined? Here do we have to mention the sample size of one group or combined? Where? Where we have to mention? When you are writing paper or writing your thesis, synopsis, you have to mention your formula. Okay? It will be very beneficial and you have to calculate manually. This is more reliable than using these calculator. Okay? But how to use these calculator, I told you. I demonstrated you. Okay, thank you very much. You have the when you click this link, you have these blank space. You can fill and you can do. You can send me WhatsApp. Okay, I will show you. Okay, thank you very much for today's. Okay, ji. Thank you. Thank you. Thanks to all.